is section 2.5 on transformations, problem number 36. So I have a graph y equals f of x, and I'm told that it has x-intercepts of -8 and 1. So if I'm doing a problem like this, I want to visualize it. Maybe you don't have to, but I do. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. I make a graph, and it's telling me my intercepts are -8, so that would be right here, and +1. Remember, x-intercepts are where the graph is crossing the x-axis, where y equals 0. So I could think of that as a function. These 2 points are just a function, but I kind of like to be a little more visual. So, I'm going to draw a little function here so I can kind of see what the function might look like. I mean, I could just make it up. You don't need to do it at all. But it's asking me, I'm going to do a couple of these questions. The first question it's asking me is, what are the intercepts, what are the x-intercepts of the graph y equals f of x plus 4? Well, I want to look at this, and I can look at my template, which I just put on here, and I can see that this 4 right there, it's inside the function. It's being added or subtracted. It's being added. So that is an h or a c, depends on whether which one you want, which terminology you want to use. So that means it's going to move the graph horizontally, and it's going to move the graph horizontally by -4. My h is -4. So every point on my graph is going to move horizontally -4, including my intercepts. So I'll take this intercept right here, and I'm going to go 1, 2, 3, 4 to the left. And this intercept here, I'm going to go 1, 2, 3, 4 to the left. So I can see that my new intercepts are -12, 0, and -3, 0. Same y values. So looking at a different part of the same problem, it's asking me, what are my x-intercepts for the function 2 f of x? Well, 2, I can see, is an a. It is outside of the function. If it's outside of the function, it affects the y values. So I want to take my y values and multiply them by 2. But these are x-intercepts. The y values are 0. This is the point -8, 0, and this is the point 1, 0. So if I multiply my y values by 2, or by 3 or 5 or 10 or a half or anything, they are going to remain at 0. They are not going to change. And just to give you an illustration of that on a different graph, on the calculator here, I have put the graph of y equals x squared minus 5. And now I'm going to do the graph of y equals 3 times x squared minus 5. So x squared minus 5 is my function. I'm multiplying it by an a of 3. So you can see it right here. I'm going to let that one show, and I'm going to graph it. And you can see it maintains the same intercepts, but it stretches the graph vertically, because it's an a, by a factor of 3. Let's do one more of these. Let's do y equals f of -x. Well, that negative sign is inside the function. That is the same thing as a b of -1. What it is telling me is that it wants me to reflect the graph over the y-axis. All of my x values on my parent function, which is the black one that I drew, which I know has these 2 points, which are the only points that I'm concerned about, are going to be reflected over the y-axis because they are inside the function. They're going to change the x values. So, well, this point over here was the point 1, 0, and this was the point -8, 0. So my x value is going to change from -8 to +8, and my y value is going to change, my other x value intercept is going to change from 1 to -1. So my new intercepts for this function here will be the points -1, 0 and 8, 0. I simply flip the graph over the y-axis, and my key points there were my intercepts.